Hi guys, today I'm going to cover the last lesson for Unit 4A, Energy Transfer and Climate. Okay, first of all, I would like to talk about how energy can be transferred from one place to another place. Okay, so we understand the structure of the Earth's atmosphere, right? And our atmosphere is the air layers protecting us from the energy coming from the outside space, especially coming from the sun. So once the energy is absorbed within the Earth's atmosphere system, the heat can be transported in three different methods. So that means the heat, the thermal energy, can be transported by three different ways. First one is called radiation, then conduction, and convection. Okay, these are the three different ways a heat can be transferred. Okay, first of all, the radiation. Radiation is the transfer of heat by the wave motion. The heat, light, and other kinds of waves radiate through the near vacuum of outer space from the sun to the earth. So this is basically how the heat can be one way for the heat energy to transfer from the sun to the earth. The energy is carried by the radiation. So radiant energy examples. How does that work? So the sun is going to warm the surface of the planet. For example, like this, the sun is directly radiating the heat energy to the surface of the earth. And also the second example is that the apparent heat of the fire. So whenever you have the open flame, the energy is going to radiate out of this. And then the fire that you see, it is the radiation of the heat energy. Second example, second types of the energy transfer is called conduction. And conduction is a transfer of the heat by the collisions of the molecules. Okay, so the heat energy are moving by the molecules, but molecules are not going to move. Molecules are going to stay in their own place, but the heat is going to be transferred from one molecule to another molecule. So the metal conducts the heat energy very well. Air and liquid insulators are poor heat conductors. That's because the metal and any kind of solid have the high density. So the molecules are right next to each other. They're packed closely together. So the heat energy can be transferred from one molecule to their neighbor molecule much easier. Simply the proximity between two molecules are very close. Here is an example. The conduction is the molecules that transfer the kinetic energy through the vibration or collisions. So let's just say that these little yellow balls represent the molecule, typically in a solid. And then once the one molecule gains the heat energy and starts vibrating, and that energy can be transferred to the next molecule and the next molecule and so on. So the molecule itself is not going to be moving except just vibrating on their own spot, but then energy will be transferred due to the vibration. And again, the solids are the best for the conduction because of the high density and how the molecules are packed together in a small space. The last one is called convection. Convection is the transfer of heat by the actual movement of the heated material. So, unlike the convection and conduction, you need to be able to compare and contrast. Convection and conduction are similar in a way that the heat transfers by some kind of medium. So there has to be some kind of matter that transfers the energy. Okay, so convection also transfers by the help of the some kind of molecule. Okay, some kind of chemical molecule. The difference is that for convection, the molecule that contains the heat energy, right, is actually going to physically move to transfer the heat energy. So these molecules are basically the conveyor. Okay, they're gonna carry the heat energy with their body for the molecule, and they actually move together along with the heat. So for that reason, convection is usually done by the liquid and gas. That's because liquid and gas has a high mobility because they have a lower density than the solid typically, and they're free to move. So here is an example. So convection occurs in an atmosphere. So due to the density difference between the cool air and the warm air, right? You should know that the cool air is going to sink, and then a warm air is going to rise. Okay. So, whenever these air are actually moving, such as cool air moving down, and warm air rises, the air molecule is actually carrying the heat energy. So, this is basically a convection in our atmosphere. Conduction. Conduction is the energy transferred by the actual molecule, but only through the vibration or collision. So, the matter is actually move, the only heat energy will move. This can only work for the lowest atmosphere touching our surface, you typically up to only 6 feet. So when the heat energy reaches down at the very surface level of the Earth, the heat energy is going to make the molecules vibrate or collide into each other, so the heat energy will transfer. But again, this is going to only work up to probably 6 feet above the ground level. And beyond that, the convection is going to cause the air molecules to actually move, right? And then carry the heat energy with it. So this is going to be very important factor for the atmosphere and climate on our planet. So the equator, right, which is basically the which gets the direct sunlight, right, the perpendicular to the sun, which is going to get the most heat energy. As you can imagine, all the countries when you place near the equators are very hot during summer, and typically their average temperature is the highest. Think about like Hawaii or any kind of Caribbean countries which are on the equator, right? They are much warmer than other places on the planet. So when the equator gets heated up, the air is going to be typically warmer than other places. So their air is going to rise, the rise. So as you can see that on this section of the picture, air is going to rise compared to the other sections. Same thing over here. And then what's going to happen is that they are going to be able to travel to the now different places. And then sometimes the air is going to go toward the pole, each pole. But then the poles are very cold because they are not getting as much sunlight as other places. So that this air gets to cool it up, so they are going to sink. And again, they're gonna start traveling, so the air circulates. Okay, so this is how the wind and then the atmosphere moves around the atmosphere. So this is a great picture to demonstrate all three kinds of heat energy transfer. First of all, let's go ahead and take a look at the conduction. So if you look at the handle, right? The handle is the one that's going to actually physically transfer the heat energy because of the vibration of the solid material of the handle, right? Heat is transferred by metal atoms by vibration. So you know that these metals are not going to melt down, or they're not going to move around um, everywhere, right? So, but heat energy can be still transferred, right? And um, and then again, the metal atoms actually do not move to conduct the heat, right? Only heat is going to be transferred. Now, convection, on the other hand, is heat is transferred by the liquid atoms by the motion. So the liquid atoms actually move to transfer the heat, right? And that is a key difference with the conduction, right? The molecules are actually moving for the convection. In radiation, there is no molecules needed. Okay, radiation does not need any chemical molecules to transfer heat. They will just directly be transferred. Well, think about it. Space between the Earth and the Sun, there are nothing. It's vacuum. It's just space, and therefore the energy is going to be able to transfer from Sun to the Earth mainly by the radiation, because there's no medium to transfer the energy, right? Okay, how do energy transfer affect the weather? When a land mass is adjacent to a body of water during the day, it causes a sea breeze, right? That's because when you compare the land and the water, land gets actually heated up much hotter. Okay, much the land is the soil is going to get heated up much faster. That's because the water is very difficult to heat up. Okay, we're gonna learn about this later, but there's something called a specific heat capacity, and water is simply very difficult to heat up. So during the daytime, when the sun there's a plenty of sunlight energy, the land gets heated up faster than the water, so the air will rise from the land, and then to fill up that empty space, the air has to move from the above the sea. So the air is gonna go towards from the water to the land, and we call that a sea breeze. That kind of a wind that we will experience during the day at the near the ocean is called a sea breeze. A sea breeze happens when the land heats up faster than the water because of the water's extremely high specific heat capacity. Here is a demonstrational picture. So again, when there's a sun, the land gets to heat up first. So the air is going to rise, and they are going to circulate and come over the water, and they're gonna cool down, because again, water is much cooler compared to the land, right? Which is the reason why whenever you jump into the water, you feel much colder than outside. And then air is going to move this way, right? And that's called the sea breeze. Well, so how does that affect us? So let's take a look at this the climate in Southern California. So as you can tell, right, during a typical summer day, right, the temperature on the cities located on the shoreline are much lower than the temperature of the inland cities. So let's take a look at Santa Barbara, Los Angeles, and San Diego. Their average temperatures typically like mid 70s, right? And as you go more inside of the land, right, the temperature average will quickly rise. That's again because as you go to the inland, there are no close body of the water, which will supply the sea breeze, right, to keep the cooler temperature. So as you go down to the Palm Springs or San Bernardino, their temperature easily goes beyond 100 Celsius. I'm sorry, not Celsius, 100 Fahrenheit.